Hi, everybody. Today we're looking at Lesson 3, Collecting Data. And this lesson is mostly a vocabulary lesson, so there's really no algebra in it. It's a really interesting lesson, though. I think you're really going to like it. So the first thing we're talking about here is identifying sampling methods. And if you look at, this little diagram right here, we're going to identify the variable of interest, okay, whatever we want to study. We'll choose a sample that we believe is representative of the population. We'll collect some data. We're going to organize the data. And then the most important part of the process is at the very end where we sort of summarize the data and interpret the data. And then we can make inferences and we can draw conclusions about the population. All right, so I saved you from some writing here. I have the definitions already here, but I'm just going to highlight some key words as I go through these. So if you, I think it would be helpful if you have a highlighter or something where you're sort of circling keywords. So there are several different types of samples. We have a self-selected sample. Members of a population can volunteer to be in the sample. So the key word here would be volunteer. In a systematic sample, a rule is used to select members of a population. For example, we would select every other person. So let's highlight the word rule. In a stratified sample, a population is divided into smaller groups that share a similar characteristic. So let's highlight smaller groups and characteristic. A sample is then randomly selected from each group. So that's a stratified sample. A cluster sample, and a lot of people get confused between stratified and clustered. A clustered sample is a population that is divided into groups called clusters. All of the members in one or more of the clusters is selected. So that's the difference. In a stratified sample, a sample is randomly selected from each group. We still have groups when we talk about a clustered sample, but we're going to pick everyone in the cluster when we talk about that type of a sample. And the last one's pretty easy. A convenient sample, only members of a population who are easy to reach are selected. So if I wanted to understand how e-learning is working for students across the country, I would probably just be able to poll my students. So that would be what we consider a convenient sample. So let's just highlight easy to reach. All right, so example A, identifying types. So you want to determine whether students in your school like the new design of the school's website. Identify the type of sample described. So we've got 6 here to try. I think it would be a good idea for you to pause the video right here. Give a shot at them. Make sure you're, understanding what all the different types of samples are and see what you think. And then start the video back up to see what the answers are. All right, so number 1, you list all the students alphabetically and choose every 6th student. All right, so that would be an example of systematic. So we're going to write, because we're using a rule, this one is systematic. You mail questionnaires and use only the questionnaires that are returned. All right, so students can choose whether to respond. Just going to make a note here. Students can choose whether to respond. So that would make this a self-selected sample. All right, the next one says you ask all of the students in your algebra class. All right, so these are students who are readily available. So in this case, we have a convenient sample. Let's just add the word sample here. You randomly select 2 students from each class. Okay, so you have the students are divided into similar groups, all right, and 2 students are selected from each group, all right? So since you're, you know, grouping by classroom, let's make a note of that, right? We're grouping by class, and then we're randomly selecting some of the students. All right. Not all of them, just some of them. That would make this a stratified sample. All right, the next one, you divide students into your school according to zip code. Then you select all of the students in a particular zip code. So we're grouping by zip code. Select all students. So that's going to be a cluster sample. Right, so stratified, you're only picking some from the group. Cluster, you're picking everybody from the group. And then it says describe another method you could obtain a stratified sample. And I'm sure there are many, many, many just different answers here. What I have down here is small groups that can share a similar characteristic. For example, you randomly select 2 teachers who live within 5 miles of the school. So again, when we're talking about stratified, we're talking about small groups. Only select some. All right, and my example was you randomly select 2 teachers who live within 5 miles of school. So you group teachers by, oh, you live within 5 miles, you live within 5 to 10 miles, you live within 10 to 20 miles, and then you pick one of those groups and you only select some of the teachers, right? So that would be stratified. All right, so let's keep going. The next thing we're going to talk about here is bias. All right, a bias is an error that results in a misrepresentation of the population. In order to obtain reliable information and draw accurate conclusions about a population, it's important to select an unbiased sample. A sample that overrepresents or underrepresents part of a population is a biased sample. When a sample is biased, the data are invalid. Now, notice the word data is used in both a singular and a plural context. All right, so we have some examples here, 7 and 8. Again, this is where I would pause the video and I would see if you can decide whether or not, first of all, identifying the type of sample and decide if it's biased or not. All right, so number 7, a news organization asks its viewers to participate in an online poll about bullying. All right, so this is a case where viewers can choose whether or not to participate. All right, so this is going to be self-selected. All right. And I would say that this is a biased sample because people that are going to actually take the time to fill out a poll about bullying probably have a very strong opinion about bullying. Maybe they have personally been bullied and they are very anxious to give you their information and their thoughts on the topic of bullying. So this one is self-selected and it's also biased. Number 8, a computer science teacher wants to know how students at school most often access the internet. The teacher asks students in one of the computer science classes. All right, so first of all, because we're selecting students that are readily available to the teacher, that is, of course, going to be a convenience sample. And is this biased or not? All right, this sample, I believe, is biased because the other students in school may not have the opportunity to be chosen because they're not in the teacher's computer science class. So this is another example of a biased survey. All right, so let's take a look at selecting an unbiased sample. How would we do that? All right, here's an example of how to do that. You're a member of the yearbook committee. You want to poll members of the senior class to find out what the theme of the yearbook should be. You've got 246 students in the class. Describe a method for selecting a random sample of 50 seniors to poll. All right, this is just one idea. This is one way of doing it, just to give you an example. We're going to have 3 steps here. So in step 1, we're going to number each senior. We're going to give each senior a number from 1 to 246. All right, in step 2, we're going to use our calculator feature, the randint feature, to generate 50 numbers from 1 to 246. Now, you've seen me do that in class. When I sort of want to kind of call on you randomly, I can use the calculator. So we're going to use the randint feature where we would go from 1 to 246 to generate 50 numbers for our survey. Okay, so those numbers would be pulled. We would ignore any duplicates. All right, and we would pick 50 numbers. And then step 3, we would just go ahead and choose the students who had a number that we pulled. So choose the 50 students with the corresponding numbers. Now, you could certainly do that with a computer program as well. All right, you could do it by labeling, little pieces of paper, 1 to 246, putting them in a hat, and then randomly pulling 50 numbers. Lots of different ways to approach that, but just to give you a sense for what we mean by an unbiased sample. All right, now we're going to look at analyzing methods of data collection. And again, I have all the vocabulary filled in. It's a lot of writing, so I just want you to highlight keywords. There are several ways to collect data for a statistical study. The objective of the study often dictates the best method for collecting data. So an experiment is where we impose a treatment on individuals in order to collect data on their response to the treatment, or the treatment may be a medical treatment, or it can be an action that might affect a variable in an experiment. So keywords to remember with an experiment: you're imposing a treatment. All right, next page here, observational study. That's when you observe individuals and measure variables without doing any controlling, not changing anything. You're just simply observing individuals and measures of variables. A survey is an investigation of one or more characteristic of a population. In a survey, every member of a sample is asked one or more questions. In a simulation, you use a model to reproduce the conditions of a situation. So keyword, using a model, so that the simulated outcomes closely match the real world outcomes. All right, again, I would suggest right here, you pause the video, you see if you can identify the method of data collection for each of these scenarios, and then restart the video and see if you got them right. Best way to test your understanding. All right, number 10, a researcher records whether people at a gas station use hand sanitizer. So nothing really, there's no treatment, there's no survey. This person is just literally watching people. Okay, so this would be considered an observational study. A landscaper fertilizes 20 lawns with regular fertilizer and 20 lawns with a new organic fertilizer. The landscaper then compares the lawns after 10 weeks and determines which fertilizer is better. So here we have a treatment imposed, so this one is an experiment. A researcher uses a computer program to help determine how fast an influenza virus might spread within a city. Wow, very appropriate, right? Certainly looking at a lot of that happening in our news today. So for this one, and we hear all the time on the news about models and predictions. This is what we're talking about. This is a simulation where we're using computers to take data, to create models, right? Do a simulation, create our models, and make predictions about the future. Number 13, members of a student council at your school ask every 8th student who enters the cafeteria whether they like the snacks in the school's vending machine, right? This one, we're kind of polling students. This one is a survey. All right, last page. Recognizing bias in survey questions. When designing a survey, it's important to word survey questions so they do not lead to biased results. Answers to poorly worded questions may not accurately reflect the opinions or actions of those being surveyed. Questions that are flawed in a way that leads to inaccurate results are called biased questions. All right. You want to avoid questions that, number one, encourage a particular response. For example, if I said, if I had a survey question that said, would you rather read a boring book or watch a very exciting movie? Right? That would be encouraging a particular response. Another thing you want to avoid when you're writing these questions, do not provide enough information. Avoid questions that do not provide enough information to give an accurate opinion. Make sure your question is very clear. Avoid questions that are too sensitive to answer truthfully. A lot of times in my stat class, my students are doing surveys because we're going to be collecting data. And I always tell the kids, really try to stay away from the question about GPA. Even in volunteer surveys, students tend to lie or, slightly elevate their GPA because that is a very sensitive question for people to answer, right? So avoid questions that are too sensitive to answer truthfully. And lastly, avoid questions that address more than one issue. Keep it simple. All right, so we're going to identify and correct bias in survey questioning. A dentist surveys his patients by asking, do you brush your teeth at least twice per day and floss every day? Explain why the question may be biased or otherwise introduce bias into the survey. Then describe a way to correct the flaw. Okay, I would pause here, write down your answer, and then restart the video. So, way I would look at this is I think that a dentist point blank asking you if you brush your teeth every day, twice per day, and floss every day, people are just going to respond yes. So I think patients who brush less than twice per day or don't floss daily, you might be afraid to admit that because the dentist is the one asking the question. So first of all, patients may be afraid to admit no, right? Because the dentist is asking the question. I mean, I pretty much am one of those people that will just say, yeah, I'm doing that. I try to floss every day, but it doesn't always happen. All right. And then how could we improve this? Maybe have some sort of like paper that, the patients could fill out and drop in a box that would be completely anonymous. So I'm just going to make my suggestion here. All right. Paper anonymously placed in a box. And I'm sure you guys have lots of other great ideas. I'm not saying this is the only answers, but just to give you an idea and a sense for what would be a bias question and how to correct it. All right, I hope you enjoyed this video. This is a very different kind of math, and it's really, kind of a nice break from, the rigors of algebra. All right, thanks for watching. Hope you have a great day.